And now our first real practice involving a real-life roller coaster. We're going to watch the Manta roller coaster. I have a video of it. We're going to use it to help us calculate the average speed at that top point. So, to begin with, let's take a look at our video. Okay, doing work on it, right? Doing work, pulling it up. We want to figure out then the speed at the top when it's just about to be released. Alright, so now we want to figure out, by going back to our video, information on, in order to find the speed, the length of the train, and the time. So let's go back to our video and see if we can figure out some of that information. Alright. Now, if we look at where our people are at, right about there, let's estimate how far apart it would be from here to there. So in other words, spacing between the rows. And let's just say that the length between them is about, let's say like 10 feet. And we want to convert that then into meters. If we do that and we take our 1 meter equals 3.28 feet. And as a result, we'll get the spacing between as 3.05 meters. Okay, now we want to figure out how many rows are there. So let's go back to our video again and see if we can figure out the number of rows. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 rows. So we have 8 rows then. And if we want to find our velocity, we're going to take the number of rows, minus 1, times the spacing between our rows, 3.05 meters, divided by, okay, now we need to find our time. All right, so I want to figure out how long it takes for the train to pass by this top point. So just for ease, let's use a place that's really close to there. Whenever our first row crosses this particular piece of metal, we're going to start our stopwatches. And then when the last row crosses that same bar here, we're going to go and stop our stopwatches. So, okay, pull your stopwatch. Let's get this ready and see what we come up with. Okay, ready? All right. Let's start our time. On your marks. Get set. First row is almost there, and start. Stop! Okay, what did you get? Well, since I can't really hear what your answers are, I'm going to have to go and write down what I came up with, and I hope yours is somewhere close. I ended up getting 6.9 seconds. So my time was 6.9 seconds for that train to cross. All right, let's plug it in. So 7 times 3.05 divided by 6.9 seconds. And that gives us our average speed at the top being about 3.1 meters per second. Yay, we've calculated our first velocity, which will then go into finding our kinetic energy and being able to analyze the rest of our roller coaster. Okay, so I want to watch one more, so let's look at one more clip. And this is the Top Thrill Dragster. I really want to go on this one, so... But let's watch it before we start to do our actual analysis here. Right there is where we're going to want to figure out our velocity information. Okay, let me see if I can move this back now. I'm going to see if I can get a little bit better clip. Right there. We can start to take a look at what the spacing looks like for our coaster. It's a little hard to tell in this video, but there's a row here, here, and, okay, 1, 2, 3, 4, there should be 5 rows on this. So 5 rows. And with that, the spacing is about 1.5 meters between each row. Okay, so now let's see if we can go and figure out our time that it's going to be taking for our dragster, our train, to go from the first row to the last row at the top point. So pull out your stopwatches. Let's check it out. Check it out. Check it out. Okay. Okay, you can see it's going to go really quickly. We're going to start, and what I'm going to do when I hit the start and stop, we're going to have it start when the first row, okay, so when the first row crosses this bar, there's actually a bar right here at the top, and then when the last row goes by that bar, we're going to have you stop then, and stop your stopwatch. Okay, ready? Go! Stop! Oh my goodness, very fast, right? I don't know, what did you get for your time? Hopefully somewhere around maybe about 1.3 seconds, give or take. So with that, we can now do our calculations. Okay, so and you can see the rows a little bit better up here. So the idea then is if we want to find our velocity, we'll take our 5 rows minus 1 to get the number of rows and the spacing, the number of spaces between those rows. And then the length of that space is 1.5 meters, divided by my 1.3 seconds for the time at the top, which means that at the top, it is going 4 times 1.5 meters, divided by 1.3 seconds, and that would give us 6 meters per 1.3 seconds. And calculations, let me check it out real quick. I get 4.6 meters per second at the top. But this is actually one of the fastest roller coasters in the area, and it does, like I said, awesome, huge speeds. You should look up the stats, but this is how fast it's going just at the top. So just at the top, 4.6 meters per second. And just because I'm geeky, I actually just went and looked it up. It goes from 0 to 120 miles per hour in less than 4 seconds. And then almost immediately after, it takes you up to 420 feet up in the air. So even though the ride's only 17 seconds, like I said, I think it'd be amazing and pretty cool. So, but the real key part when it comes to our analysis is velocity of 4.6 meters per second at the top. So now an example problem that will be very similar to the speed calculations worksheet that you're going to be doing in order to finish and complete this module. So an example of a problem that you'd see would be something like this. You notice that there are 6 rows for your train with 1.5 meters between those rows. So when you walk up to the gates, you see that there are 1.5 meters between, and you also collected using your stopwatch. It's 2.4 seconds to pass the highest point. So if we have our little train up here, I'm not drawing it very well, but you get the gist. We have our 6 rows. At the top point where that flag is, that's going to be my highest point, and we want to go and figure out how fast it's moving there. So all we care about is just the spacing between the rows. Okay, so let me see if I can draw this. This is a dragon, in case you're wondering. I decided there was going to be a dragon for my rows here. So the rows are going to be signified here by people. So row 1, row 2, row 3, row 4, row 5, and then we have row 6. And here's my dragon. Whoa. That's my roller coaster. And we have our 6 rows. So what we notice then, and when we collect our data, is that between these rows, we have 1.5 meters. And as a result of that, we're going to be able to go and calculate our distance between our first person and our last person. So to do that, we'll use our velocity equation, we know we have the number of rows. So we have 6 rows minus 1. 6 rows minus 1 times the spacing between each row. So 1.5 meters divided by the time of 2.4 seconds. So once again, we're using that length of our train over time. And when we do that, we'll go through and we'll get 5 times 1.5 meters divided by 2.4 seconds. And it should become 7.5 meters divided by 2.4 seconds. And let's plug that into our calculator. And I got a velocity of 3.1 meters per second. So 3.1 meters per second is how fast it's moving at that top point over at A. Now a couple helpful reminders as we get going. We know if we're going to be talking about anything involving length and displacement, we're going to want to make sure those are using units of meters. So we need meters for that. When it comes to time, anytime we talk about time, we're going to want to be using units of seconds. And as a result, when we get to velocity, we'll then have meters per second for our units. I also want to point out the conversion. 1 meter is 3.28 feet. Make sure that if you see a problem on your homework where they talk about feet, that you make sure to convert it right away into meters so you can use your metric units. All right, you are now free to spread your wings and fly and make this happen and practice these problems on your own. And the way you're going to do that is by going over to your Module 1 and find the speed calculations. So speed calculations, which is handout 1A. So if you could go over and do that, that would be excellent. Finish up that worksheet, and as soon as you're done with that worksheet and you have the correct answers and you've worked through those all and shown all your work, then submit that using the file submission form. And then you should be good to go. Once you're done with Module 1 and you've turned that worksheet in, then you're going to want to move on to Module 2, and yay, we are moving right along. Let me know if you have questions, and have fun.